All right. We were talking about how numbers have two sides. Okay, how 0 has two sides. Today we're going to be focusing on how infinity has two sides as well. There's the positive side of infinity, and there is the negative side of infinity. So you've got both sides. So our limits today are all going to bring us into dealing with positive and negative infinity. We're going to talk about limits that have 0 in the denominator. Okay. Now again, remember one of the fundamental rules of math is you can't put 0 in the denominator. And we're saying we're not putting 0 in the denominator. We're going to put 0 minus in the denominator, which is not really putting 0 in the denominator. We're going to put 0 plus in the denominator, which is not really putting 0 in the denominator. All right, so we are learning how to cheat the system a little bit. Okay, we're not technically doing something wrong because the rule says 0 and I'm not using 0. And that leads to an asymptote. Okay, when you do that, when you divide by 0, either side of 0, that will lead to a different kind of asymptote. All right, so a little logic. When you divide something by a larger number, when the number on the bottom is bigger, what happens to the answer? Okay, what direction does it go? Does it get bigger or smaller? Smaller. Okay, when you divide by a larger number, you get a smaller result. Okay, and when you divide by a smaller number, you get a larger result. Mm-hmm. Didn't the numerator still go down? So, okay, so yeah, we're talking about numbers that are, I should say, smaller like than 1. Like we're talking like, 0.1s and things like that. So, what happens when you divide by 0? Okay, so we need to reframe our minds now. It's not undefined, we're actually defining it. Okay? Okay, yeah, when you divide by 0, we are going to define that. It's no longer going to be undefined. Okay, to divide by 0 leads to infinity, but it leads specifically to one side of infinity or the other. Okay, so we're going to divide by 0 plus, and that will lead to one side of infinity, and we'll divide by 0 minus, and that'll lead to the other side of infinity, and depending on what the numerator was as well. You need to know the sign of the numerator. Okay, so the answer to that is one side of infinity or the other. So we get plus or minus infinity. Okay, so 2 divided by 0 does not exist. You're right, that is not defined, that does not exist. But 2 divided by 0 plus, we are now defining that as being positive infinity. You end up on the positive side of infinity because both 2 and 0 are both positive, 0 plus are both positive numbers. And then 2 divided by 0 minus is going to lead to negative infinity because we have a positive number divided by something on the negative side. So positive divided by negative is negative. All right, so here's an example. If you try plugging in 1 and you do it numerically, you're going to get negative 3 times 1 over 1 minus 1, which is negative 3 over 0. Okay, that doesn't exist. And so instead, we evaluate either side of this. So we're going to evaluate 1 minus, and we're going to evaluate 1 plus. And we'll plug that into each of these equations. Okay, so we'll get negative 3 times 1 minus, and we'll get 1 minus minus 1. So just remember on which side of 1 we're talking about. The denominator here because I'm on the smaller side of 1, I will end up on the smaller side of 0. So that ends up to be 0 minus. The numerator ends up to be 3 minus. What did I miss? Oh, thank you. All right, now you gotta be careful about the difference between the little minus sign and a negative sign. Okay, we gotta count like how many negatives and stuff we have here. All right, how many of these, how many negatives do we have?
1 negative, 2 little minus.
Okay, so you're seeing 2 of these, okay, like that. All right, but I want to point out what they do. Okay, this one right here, does that change the nature of the -3? Because no matter what side of -3 you're on, you're still what? You're still negative, okay? So no matter what, this is a negative number. All right, what about that one? Depending on what side of 0 you're on, does that change the sign of that number? Okay, so what's the sign of that one? Negative. So how many negatives do we have? Which means the answer to this is going to be a positive. We end up on the positive side of infinity. All right. Now for this one, this is easier because we're dealing with positives. -3 times 1 plus minus 1. This is more clear. I end up with -3 plus. I end up with 0 plus. So again, what side of the number are you on, and does it change the nature of that? So the numerator is still a negative number because no matter what, if you have a plus or minus, it doesn't change the nature of -3. But in the denominator, we are on the positive side. And so we end up on, since we have 1 negative and 1 positive, we end up on the negative side of infinity. This is algebra, but this is confirmed by what you should know about this graph. Okay? What kind of graph is this? It's a hyperbola. Remember what hyperbolas look like? These things? Okay? One side of the graph is going to positive infinity, one side of infinity. The other side of the graph is going to negative infinity. All right, and so it's totally confirmed by what you know visually is happening. Where is the asymptote? At the number 1. Okay, why is it at the number 1? You just have to look at the denominator there. Okay, that's 1 to the right. And so we've got, all right, so if we're thinking visually now, there is an asymptote at 1. And we know that, according to the algebra we did, that the left side of 1, okay, 1 minus, the left side of 1 ends up shooting towards positive infinity. So when I want to draw my graph, the left side of 1 is shooting towards positive infinity. And the right side of 1 is descending down towards negative infinity. Now there's also a horizontal asymptote in hyperbolas. So there's an asymptote that goes across here, and we'll talk about that in just a minute. But we're just looking at our vertical asymptotes right now. Okay, so the algebra confirms the graph confirms the algebra. Okay, okay, the next slide is all the same thing. I guess I was maybe thinking I would do that on that one. Okay, you can delete that if you want. All right, so numerically, we resulted in infinity. Graphically, we get a vertical asymptote. So if you end up numerically with any answer that's on either side of infinity, that means your graph has a vertical asymptote there. All right, so this is to summarize it formally. The line x equals a is a vertical asymptote if if either you end up on either side of infinity based on either side of A. So no matter where A is, okay, so if A is here, and you have a vertical asymptote there, it's because one side or the other of the graph was approaching. Now they both could approach the same thing. You could have both sides approaching positive infinity. So it could go up like this, and the other side is also going up like that. What's the name of that graph? Do you remember? Inverse square. Okay, this is called an inverse square. It could be, you know, like this, where one side they're doing opposite things. That would be a hyperbola. Okay, or they could be reflected. But that's how you know. If the result is positive for negative infinity, you know you've created, or there should be a vertical asymptote. Okay. All right, so where's the vertical asymptote here? Okay, the vertical asymptote's at 2. So automatically, you should draw a vertical asymptote at the positive value of 2. Okay. And then to confirm which side is doing what, you can use limits algebraically. So we're not looking at our graphing calculator, but we're using limits to confirm which side is going in what direction. So then we look at, all right, the limit when I'm approaching 2 from the left, what side of infinity should I be on? And the limit as I'm approaching 2 from the right, what side of infinity should I be on there? Okay, and then you do the algebra. You plug in 2 minus, and you plug in 2 plus. And then your numerators are both over a version of 0. So then you got to know, okay, is that sending me to positive or is it sending me to negative infinity? All right, so looking at the top option, which is the left side of this asymptote, the numerator is 2 minus, but still a positive number because 2, no matter what, either side of 2 is still positive. And then I've got a positive divided by a negative. So that is going to send me to negative infinity. So this graph would be coming down, and on the left side I'd be going to negative infinity. And the other one are 2 positive numbers, so I'll be going to positive infinity. And so my graph will be shooting up to infinity and beyond. Okay, that way. And then we'll talk about the horizontal asymptote coming up. There is a horizontal asymptote as well. And we'll talk about where that is. Okay, how about this one? Oh, sorry. Any questions on that? Okay, how about this one? Vertical asymptotes? Okay, 2? Plus or minus 2. There's 2 kinds of vertical asymptotes. Okay, there's both. Because I could plug in 2 and get 0. I could also plug in negative 2 and get 0. So this one's going to have 2. All right, great. So I'll have 2 vertical asymptotes. So I want to check both sides of both asymptotes and see what's going on. Okay, both sides of both asymptotes. Okay, so let's do the positive asymptote first. Let's check 2 minus, and let's check 2 plus of 8 over 4 minus x squared. All right, so I'm going to drop my 8 is my numerator, 4 minus, and then I'm going to put 2 minus into something squared, which is going to give me 4 minus. So 8 over, okay, what do I end up with? Which one's bigger, 4 or 4 minus? The first number or the second number? Okay, 4 is bigger than 4 minus because 4 minus is a little bit less than 4. And so I end up on 0 plus which means I'm on the right side of infinity, the positive side of infinity, but on the left side of the asymptote. Okay, does that make sense? We're on the left side of the asymptote, but I'm heading towards positive infinity. So that means I'll be doing this. I'm on the left side of the asymptote, but I'm heading towards positive infinity. The other one will be 8 over 4 minus 4 plus. That'll be 8 over 0 minus, because it's 4 minus a bigger number, so that's negative infinity. So I'll be on the right side of the asymptote, but I'll be heading towards negative infinity, so I'll be coming down like that. That's what's going on around that vertical asymptote. Yeah?
Did you get the negative over the 0 for the second one again?
In my head, I did this. I did 4 minus 4.001. I picked a number that was like bigger than 4, okay? And anytime you put the smaller number here and the larger number second in subtraction, you end up with a negative number. When you do a smaller number minus a bigger number, you always end up with a negative. Okay. All right, and then we do the same thing. I can't erase that, I don't know why. On the other side of the asymptote. And you would put in, okay, now let's look at what negative 2 minus does, and how is that going to end me up? Okay. Just to speed things up a little bit, the limit as we go from negative 2 minus of 8 over 4 times x squared is going to give me 8 over 4 minus 4 plus, which again is going to be negative infinity. And then the last one will be 2 plus, negative 2 plus, which would be sending me to positive infinity. So this side is going to go up that way. And I kind of, that's what I end up with. That's the graph. All right, the next slide just confirms all of that. Mm-hmm. Yeah, you could move all of this down to this one if you wanted to put it all in someplace nice. So this one was negative infinity. This one was 2 left, positive infinity. This one was positive infinity. And this one was negative infinity. Yeah. Yep. Positive next to the second 4. On this slide or the next slide?
This one, because there's like as x approaches 2 from the right, you have 4 minus 4 with a positive symbol.
Because I squared it.
Okay, and then on the next one, you said we also have 4 minus 4 with a positive symbol. Is it still positive?
It's because we're squaring different sides of numbers. We're squaring, one of them is 2 on the right and the other is negative 2 on the left. Those are two different, those both result in 4 plus. Yeah.
Why did you have to do negative 2 on the right?
I said it verbally and I didn't write it down. Yeah, we should do negative 2 on the right. That's what's on the next slide. I have all 4 of them written on the next slide. So negative 2 on the right is right here.
I just got negative.
For that one, when you put it in? What happened when you squared negative 2 on the right? Positive 4 or 4 plus or 4 minus? You should get 4 minus. Because negative 2 plus is negative 1.99999.
Can you scroll back up this one?
Mm-hmm.
Catherine was trying to say on the bottom one,
Mm-hmm.
it's 2 minus, shouldn't it be minus 4 minus, since it's like 1.999, negative 1.99?
2 minus is not negative 1.99. 2 minus is negative 2.01.
So how does this work?
2. That's plain old negative 2, right? And I want to think about what negative 2 plus is, and I want to think about what negative 2 minus is. Give me actual numbers. Okay, give me something that's on the right side of negative 2. Can you think of one? No, on a number line. Negative 2.001 is here, not on a number line. Because where number lines go, 0 is here, number lines go that way. The numbers get increasingly bigger the farther you go down the number line. So 2 would be here. 2 plus would be negative 1.9999, and 2.01 is going to be there. Okay, now we're squaring these numbers. Okay, which move us to the other side of the number line, because now we're making them positive. Okay, when you square something, so look at how far, look at the distance between 0 to here. Okay, this is farther than from 0 to here, or from 0 to here. So when you square this gap distance is going to reflect over to the positive side of the number line, but it's not going to reflect as far. When I square this, I'll end up way over here at 3.99999. When I square this one, negative 2, I'll end up at positive 4, which is farther away from 0. And then when I square this one, because it's the farthest away in a negative sense, it's going to reflect over here, and it's going to be the farthest away in a positive sense. So this is 4 plus, this is 4 minus. You don't look sold. You'll figure it out. All right. Okay, one last thing about tangents. Okay, can you do it yourself? Can you write it from a graph? Instead of doing the algebra, can you write it from a graph? Okay, so we all know, we should know that a tangent graph is bounded by equally spaced asymptotes, and a regular tangent graph has like this. Okay? Can someone write for me, I can think of like 4, but can somebody write one math statement using limit that would involve this on either side of an asymptote? Okay, you try. Come on, you can do it. Okay, that's in.
Limit as x approaches pi over 2.
What side of pi over 2? You have to specify.
Negative.
Okay, the limit as this graph,
Or minus,
okay, pi over 2 from the left, okay?
positive.
Not equals, you need something here,
Of f of x.
okay, of tangent, which is our f of x right now. Okay, now you can say equals. Equals,
Positive.
great. Okay, so he just did this one. The one I highlighted in red. Okay, somebody else try another one. Okay, Rose.
The limit as x goes to negative pi over 2 plus of tan x is negative infinity.
Okay, she just did this one. Anybody else got another one? There's a couple more. Okay, Christian.
The limit is x approaches pi over 2 plus tangent of x.
Pi over 2 plus of tangent of x. All right, so you're doing this one down here, okay, because you know it's going to repeat itself, right? And then there would be another one over here that you know would repeat itself as well. So there's all asymptotes have 2 sides, and on every side of the asymptote, these graphs are going up and down. All right, great. Why don't you, yes? There is no asymptote at 0.
Oh, really? Well, then would the answer be 0?
Yes, yes, yes. If we weren't focusing on, this one just said, describe the behavior to the left and the right of each vertical asymptote. That's all we were focusing on. But yes, 100%. If I asked you, what is the limit approaching 0? And you would say, well, you tell me the one-sided of 0, you tell me the other side of 0, those will be the same, and then you can tell me that that's equal to 0. Yeah, great. All right, why don't you look up so we're going to page, I believe it's 80, okay? And you have let's do about 20 minutes or so. What does that get me? Oh, that gets me, let's do 15 minutes, okay, of work on this. So this is not a full assignment, 1.2a. Okay, it's not as long as a full assignment. It's like less than a half, maybe a third of an assignment. So why don't you get started on that? And I'll call you back. We'll circle back up in about 15 minutes or so. So vertical asymptotes are the result of when you get either side of infinity as your answer. Okay? Your answer is plus infinity or your answer is minus infinity. That's when you have vertical asymptotes. Horizontal asymptotes are where infinity is in a different place. Okay, so I just want to show you where that is. Okay, so what we just did plus or minus infinity being our result. And that is a vertical asymptote. But when infinity is the value that you're approaching, okay, so look at where now I've drawn, where the plus or minus infinity is part of the x arrow, that's going to be a horizontal asymptote instead. Okay, so infinity shows up there, and then you get a constant number like 3 or 7 or 5, that will be a horizontal asymptote. So let's look at a graph that we know has a horizontal, okay, so that's what we just said. That's the formal definition on slide 15. So on slide 16, we see a graph we know to be a hyperbola that does have both a vertical and a horizontal asymptote. So we can see the vertical asymptote. The vertical asymptote comes right down here. Okay, the horizontal asymptote is coming right across here. And what's the height or the value of that horizontal asymptote? What would you say? 1, okay? But we're on like the top of 1 or the bottom of 1. Okay, we're on the upper end or the lower end. And so looking at our part A and our part B, as the limit approaches positive infinity, so that means when you're moving out towards infinity as a positive value and you're moving horizontally now, you're going to be ending up on the top side of 1. Okay, you're never going to touch 1, but you're just going to be sitting like right just above 1 all the time. Okay, and then when you're approaching negative infinity, okay, that's the one heading out through quadrants 2 and 3. And when we're heading out that way, we will be getting closer and closer to 1, but we're going to be getting to it from the underside. You're always going to be a little smaller than 1. You'll never quite get there. Okay, and the horizontal asymptote itself, so the limits are 1 plus and 1 minus. The name of the horizontal asymptote is just y equals 1. It's the integer value. That's the name of it. Okay, so when we say x approaches infinity, it means that x is moving increasingly far to the right. And when we say x approaching negative infinity, okay, so right, I want you to think quadrants 1 and 4. And when we say x is approaching negative infinity, then we're talking about moving towards the left, which is quadrants 2 and 3. It's a direction. When y is approaching infinity, then y is moving increasingly up vertically, and when y is approaching negative infinity, that's increasingly down. That's a vertical. That's what we were just talking about before. All right, so slide 18 gets to what you can and can't do with infinity. All right, if you start with infinity and you add or subtract any number to it, what do you end up with? Infinity, very good. All right, what if you start with infinity and you add infinity already to it? What do you get? Infinity. What if you start with infinity and you subtract infinity from it? What do you have left? No.
Infinity.
No. Okay. It's this new word that you learned, indeterminate. Okay? Because there are two rules in conflict. One rule is anything minus itself is always 0, but not with this one. And the other rules in conflict is that you can't ever take anything away from infinity without having infinity left, and then that doesn't work, so we call that indeterminate. All right, how about infinity multiplied by any number? Still infinity. How about infinity times in itself? Still infinity. How about infinity times 0? Okay, because what rules are in conflict? Anything times 0 is always, anything times infinity is always infinity, but anything where 0 and infinity are both times each other, another indeterminate. So these are things you can and cannot do. You can add infinity, you just can't subtract it. You can multiply, you just can't multiply it by 0. Okay, how about infinity divided by k? Still infinity. How about infinity divided by itself? Okay, it's not what? It's not 1. Indeterminate. All right, so these are those rules. The rule that we usually think of is that anything divided by itself is 1 except involving 0 over 0 or infinity over infinity. So these are the things we call indeterminate. All right, so if you get infinity over infinity as an answer, this is how you can solve the problem. You should try dividing by the highest power of x. So you look around your problem and the highest power of x is x cubed. Try dividing everything by x cubed. Identify the highest power in the problem and try dividing, and that will take care of your infinity over infinity problem. That's how you deal with indeterminate forms. Okay? All right, so here. If I tried to plug infinity in, I would run into a problem. I get infinity plus 1 in the numerator, and we just said if you add anything to infinity, what do you get?
Infinity.
Okay, and my denominator is infinity, so I end up with infinity over infinity. Okay, so now I'm going to use my trick. What is the highest power of x you're identifying?
1.
Just plain old x, right? Divide everything by plain old x. So my work is algebraic, which is why I need my limit. So I'm going to divide x by x. I'm going to divide 1 by x, and I'm going to divide x by x. We're almost done. Divide everything by that highest power. Okay, this is algebraic, so I still keep my limit going. What's x divided by x?
1.
What's 1 divided by x? 1 over x, and the denominator is 1. Now try plugging infinity into that and see what happens. So 1 plus 1 over infinity and 1. Okay. What is 1 over infinity? Okay, remember we talked earlier. Chloe, 0 plus. Okay? 0 plus. Why? How big is infinity? It's huge, right? And when you have a huge denominator, what kind of answer do you get? No, a huge denominator gives you a very small number. So this is 1 plus 0 plus. Because it's positive, because 1 is positive and infinity is positive. So we end up on the positive side of 0. So that's 1 over 1. So the integer value is 1. And that's how you get around indeterminate forms. Divide by whatever the highest power is. In last year's video, I did one more example of that. So I'll leave last year's video posted too if you want to watch one more example of that. If we look at the limit as x approaches negative infinity, okay, so remember that means we're looking at quadrants 2 and 3 of the graph. So we're going to start with plugging negative infinity into, the same algebraic expression. So we don't need limit anymore because we're not doing algebra anymore. We're using a number. So 1 plus 1 over negative infinity over 1. So that'll be 1 plus, and that's a 0, but on the left side of 0. So that'll give us 1 minus. Okay, so if we look at what's happening now, we have a horizontal asymptote of 1 minus. That means we're on the underside of the horizontal asymptote of 1 when we're in quadrants 2 and 3. But we have 1 plus, which means we're on the upper side of the horizontal asymptote of 1 when we're in quadrants 1 and 4, okay, when we're heading out to the right. All right, so numerically, like our first try, we got an indeterminate 0 over 0. Excuse me, infinity over infinity, okay? Only when that happens, okay? Just let me clarify. Only when you get infinity over infinity can you try the algebraic technique of dividing through by the highest power, okay? So that's only in this situation when you have infinity over infinity. When that happens, all right, then we're going to get a constant algebraically, okay, because we use the technique of dividing by the highest power. Okay, that's the algebraic technique. Divide by the highest x to whatever power is present, and then graphically we get a horizontal asymptote, right? That's what's happening. So remember, the graph has to confirm the algebra, and the algebra has to confirm the graph. They go hand in hand. All right, so let's look at another one. Okay, if I drop infinity into this, so 1 minus 5 times infinity over infinity. Okay, well, 5 times infinity here, that's infinity. So this will be 1 minus infinity over infinity. Well, what's 1 minus infinity? Negative infinity over infinity. This is a version of indeterminate as well. Okay, the negative, another way to think of that is to have the negative just sort of sitting out in front. That's a negative indeterminate form. So because we have an indeterminate form, then we can back up and we can apply the technique of dividing everything through by the highest power of x. So the algebra is going to look like this. 1 divided by x minus 5x divided by x, and then the denominator, x divided by x. So what does that simplify to be? 1 over x minus 5 over 1. That algebra, excuse me, is what we're going to be plugging in infinity and negative infinity into. So our limit becomes 1 over infinity minus 5 over 1. Now remember, 1 over infinity is 0. So we're going to have 0 plus minus 5 over 1. That's going to give me negative 5 plus. So that means that the horizontal asymptote out in quadrants 1 and 4 is going to be on the upper side of negative 5. Negative 5 is the horizontal asymptote, but we'll be landing on the upper side of it. If we look at negative infinity, 1 over negative infinity minus 5, that'll be 0 minus minus 5. That's negative 5 minus. So that means our horizontal asymptote is negative 5, but we'll be on the lower side of it, the underneath side of it, when we're out in quadrants 2 and 3. All right, let's try another one. If we put infinity into all these values, if we put infinity here, 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 and here, okay, what will we get? We'll get 2 times infinity squared minus 5 times infinity plus 3 all over 3 times infinity squared plus infinity. So squaring infinity is still infinity, subtracting 5 times infinity is still infinity. We get infinity over infinity. So we have an indeterminate form. All right, so that means that we're legitimately allowed to back up and divide everything by the highest power of x.
So the highest power of x is x squared. So I'll divide this term by x squared. I'll divide this term by x squared. 3 gets divided by x squared. 3x squared gets divided by x squared, and x gets divided by x squared. So what we get is reduce. Okay, so then that gives me 2 minus 5 over x plus 3 over x squared over, and this reduces, and I'll get 3 plus 1 over x. Okay, and then we can put infinity and negative infinity into that algebraic expression. So what we'll end up with is 2 minus 5 over infinity plus 3 over infinity squared, and then 3 plus 1 over infinity. So we're looking at 2, and then minus 0 plus 0, and then 3. So we end up with 2/3, but we're on the upper side of that. So we're on the upper side of 2/3 as our horizontal asymptote. Okay, then we're going to do the same thing for negative infinity. This time we're going to end up with 2/3, but we'll be on the lower side. All right, so let's assume we've checked it. We get infinity over infinity, which means we can launch into the algebra. We can divide everything through by the highest power. The highest power is x cubed this time. All right, so x cubed means let's divide this term by x cubed, this term by x cubed, this term by x cubed. All right, what do we have? That'll give me 3 over x. That'll give me 1 over x squared. That'll give me 2 in my denominator. Okay, I'll put infinity into that. So 3 over infinity plus 1 over infinity squared over 2. That's 0 plus, and another 0 plus over 2. That's 0 plus divided by 2, which is still 0 plus. So our horizontal asymptote is 0, but we're on the upper side of that in these quadrants. When we put in negative infinity, so 3 over negative infinity, 1 over negative infinity squared, and then 2. So that'll be 0 minus, that'll be 0 plus, and that'll be 2. So we're adding 0 minus to 0 plus. Does that mean we land right on 0? It doesn't, because one of them, either the minus side or the plus side, is stronger. So one of them has, like, it's more negative, there's more space on that negative side or more space on the positive side. So let's look at what's what. Okay, because this one has a bigger denominator, its overall value is smaller. Okay, the larger the denominator, the smaller the number. And so if you're looking to compare these two, the negative one is greater than the positive one. So that negative one carries more weight to it. It has more of a pull, like a magnet. And so this is going to be pulled to the negative side. And so on that side, we would be have 0 as our horizontal asymptote, but be underneath. All right, this is our last algebraic one. Again, we plug in infinity, and we see that we get indeterminate of infinity minus infinity. Actually, we end up with, let me clarify that one. We end up with infinity minus infinity over infinity. So infinity minus infinity itself is an indeterminate form, and then over infinity is another indeterminate form. All right, so we've got all kinds of indeterminate forms. So we're going to divide by the highest power, which I identify this time as being the 4. So I'll divide everything by x to the 4th. So divide by x to the 4th, x to the 4th, and x to the 4th. See, algebra simplifies down to be 5 minus 2 over x cubed and then over 1 over x. So let's put infinity into that. So 5 minus 2 over infinity cubed over 1 over infinity. So this is 5 minus 0 plus over 0 plus. It's 5 plus over 0 plus. All right, so what happens now? Okay, this is not an indeterminate form. This is back to having 0 in the denominator. Okay, and remember that was the point of the whole other lesson that we did previously. What happens when we have 0 in the denominator? Well, that creates a positive version of infinity. Okay, and so this one does not have a horizontal asymptote at all. It has what we call a slanted asymptote. We're not going to talk too much about these, but it just means that this does not go vertical, it does not go horizontal, it's just heading up to infinity along a slant. We're not going to be concerned so much with what the steepness of that slant is or what the angle of that slant is, but it does have a slant asymptote. But the point is it doesn't have a horizontal asymptote and it doesn't have a vertical asymptote. It would be neither. Okay, neither kind of asymptote. The same thing would happen in part B. So I just want to make sure we summarize and that you take two big takeaways coming out of here. If you have any number and you divide it by 0, either plus or minus, you'll end up on the plus or minus side of infinity. Okay, if you have any value and you're dividing it by a version of 0, you'll end up on either plus or minus infinity. And then the converse is true. If you have any number that you're dividing by either one of the values of infinity, either side of infinity, your result will end up on the plus or minus side of 0. Okay, now again, how do you decide which side you're on? Well, that has to do with what k is. Okay, if k is positive, and then it counts at, or negative, it's going to count up to how many positives and negatives you have. All right, so this is just some summary rules about the things that you are and aren't allowed. You can add limits together. You can subtract limits together. Those are legal things to do. You can multiply limits together. You can pull a constant in front of a limit. All right, if you have a constant here, and you can pull it out to the front of your limit. That's legal. You can divide limits. All of these things are legal things to do when you're working algebraically with limits, okay? The big takeaway is the understanding of the difference of these two things, okay? Is it going to produce which side of infinity you're on or which side of 0 you're on? Those are two big takeaways. All right, I will see you guys on Friday. Looking forward to finishing up 1.2 with you then. Have a good night.